Previously on the Advent of Cyber. Set to have all their apps secured, the elves turn towards the one Santa uses to manage the present deliveries for Christmas. When presented with the app's code, both elves looked a bit shocked as none of them knew how to make any sense of it, let alone fix it. The elves returned carrying a pointy hat and appointed you the new Elf McCode. One of the first things I look for when looking for SQL injection is I come up to the ID parameter and I will usually put like a single quotation mark and hit return and see if you get an error. So we have replaced line 4, and then what we need to do is Control S to save and then run checks again. We have successfully patched the elf.php. Hello world and welcome to Hacks. We are back with day 17 of TryHackMe's Advent of Cyber, and the topic of today's room is secure coding, filtering for order amidst chaos. So briefly skimming through this room, it appears that the main focus of this room is about input validation and how you can add additional parameters or additional filters onto input boxes where user input is required, and it talks about the different types of data and how we can filter those more accurately. And then the exercises at the end are not necessarily secure coding practices, but showing how powerful regex or regular expressions can be in applying filters. But without further ado, the story. After handling unrestricted file uploads and SQLi vulnerabilities, McSkitty continued to review Santa's web applications. She stumbled upon user-submitted inputs that are unrecognizable and some are even bordering on malicious. She then discovered that Santa's team hadn't updated these web applications in a long time, as they clearly needed more controls to filter misuse. Can you help McSkitty research and learn a useful technique to handle that in the future? So a big part of input validation on forms is knowing what data is going to be expected of the form. So they're talking about task 15 and saying how you didn't manually type in your CV, you had to upload the file, and how that file was checked for things like content type, the extension, because they know what was expected from the upload file. And it's the same with input boxes. If you know what's going to be put into input boxes, whether it's a name, a date of birth, an address, you know what characters you should be expecting. So for example, if you've got a user form that requires them to put in their name, you'll expect characters A to Z, but you wouldn't necessarily expect numbers or things like percentages or semicolons or pipes that could allow you to escape and do a remote code execution. So by knowing what values the input box is expecting, you can then apply filters, and it's talking about HTML5 and regex here, and you can see there's a regex where it's filtering for A to Z lowercase, A to Z uppercase, and 0 to 9. And then the author does a great breakdown of regex 101, and it talks about how you can find certain characters like specific vowels, or you can do sequences, so A to Z, min and max numbers, and goes on to a lot more complicated search queries, but we're going to be getting into that later when we actually do the challenges. And while these filtering and input validation methods are great for predictable inputs like names, dates, addresses, things like that, it still presents a problem when it comes to free-form text, where you just got a big input box and the user can input anything they want to. So if they are actually manually uploading their CV by pasting it into a box, or writing an essay, or submitting a query, it becomes a bit more problematic because you don't know what characters you're expecting. Now there may be legitimate reasons to use semicolons and percentage symbols and other special characters that can be problematic in filtering out. This is where defense in depth could come into place, where you could have multiple ways to defend the application against rogue inputs. It does talk about things like having allow lists so that only certain characters are allowed, so then you can block out specific ones, but I'd say that still presents a problem because certain characters may be needed. I was recently filling out a form on a website where I had to explain certain things and certain characters weren't allowed, even single quotation marks, and it became a bit of a pain to write out what I wanted to write because I had to go back through and get rid of all the special characters. But it does talk about other remediation tactics, and they've got a few examples here of how additional types can be placed on certain parameters so that you know what you're expecting. So you've got input type is text for the name, input type is date for the birthday, so you know what format and what characters you're expecting. Then it talks about input length, so you can add input lengths on. This could be helpful to prevent things like fuzzing, where you're fuzzing really long values against the application to see how it responds, to see if you can generate errors. The author then goes on to talk about client-side versus server-side validation. Obviously, anything client-side the user has control over. It may be a good technique to ensure that the format of the data the user is submitting is correct, but in terms of providing protection to the back-end web application and preventing threat actors from doing malicious things, client-side protections are pointless. They could easily go into the source code or view the page source of the application and change the client-side script to allow them to bypass things like max character lengths. And then the author continues to explain why not all solutions are equal, and saying how trying to fully protect your application against XSS cross-site scripting attacks requires multiple layers of protection. So for instance, you'll want your cookies to have the secure and HTTP only flags set so that they can only be accessed via HTTP content and not JavaScript, and so that they are encrypted over HTTPS connections rather than being transmitted in plain text. And it talks about how you wouldn't use SSX protections to sort of protect against SQL and LDAP related queries, so that every input form needs to have its own sort of protection mechanisms in place for the different types of attack. And again, this is where defense in depth comes in, so you can have like web application firewalls, you can go through a content delivery network like Cloudflare to have that additional protection, as well as having headers in place to prevent certain types of attack, and then having allow listing on the back end of the application so that all data is validated before it gets submitted to the back and processed by the SQL server or something to that effect. So it really is a layered approach to securing applications. You can't just do it at one singular level. You're going to have to build upon it and ensure there's mechanisms in place at every step to prevent malicious threat actors from sneaking payloads through initial protections. The author does a far better job of explaining all this than I do. I don't want to regurgitate all the information and just read what they've put, but my own web application security knowledge is lacking, so I highly recommend logging on and reading through all this yourself to get a better understanding of input validation, why it's difficult, and how we can get around the sort of various problems that we face when securing web applications. But yeah, definitely jump on and give it a read. So as mentioned above, the challenges for this room aren't necessarily related to input validation. It's more about how we can use regex to find particular strings or particular values in data, but you can obviously apply the information you've gained here to filtering mechanisms on web applications. So if you've got an input, you could filter for specific things, and if the input doesn't match the regex in your filter, then it could deny that information for being processed. So we're going to go through, spin up the box and answer all these questions by hopefully putting together some regex and see how we get on. Unfortunately for us as well, we've also been given a lot more filters in place, so we know the structure of the data that we're searching for, which should make regexing for it a lot easier. So filtering for usernames alphanumeric, minimum of 6 characters, maximum of 12, so we can use min, max, and then A to Z. May consist of upper and lowercase, that'll be like A to Z low, A to Z high, 0 to 9, and then min, max. And then filtering for email, we can use the local part at domain with quotation marks, a random string, and then we can use the top level domain.com, so we know that it's always going to have an @ symbol and it's always going to have a .com, and then we can search for anything either side of that. And then we know the URLs are always going to have HTTP, HTTPS, some may have www, and some will have top level domain. So I've spun up the box and I've CD'd into desktop and regex practice, and you can see the file we're going to be working with is called strings, and the first question asks us to find all the usernames which match the following criteria. Filtering for usernames alphanumeric, minimum of 6 characters, maximum of 12 characters, may consist of upper and lowercase characters. So the first thing we're going to do is we're going to do egrep, and then we're going to put in single quotation marks, and then we're going to say start of the line, open square bracket, because now we're searching for the characters, A to Z lowercase, A to Z uppercase, and then 0 to 9. We're going to close that and open a squiggly bracket, and we want to do a minimum of 6 characters in length and a maximum of 12 characters in length. Then we're going to close that, end the line, single quotation mark, and specify the file of strings, and that should give us these usernames, which we have 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 users there, if I've done that correctly. Filtering for usernames, one username consists of a readable word concatenated with a number. What is it? So it's a word with a number at the end of it, so that's user 35. So uppercase U, submit. The next question asks, filtering for emails, how many emails fit the above syntax? So if we look at the syntax again, we know it's going to be a part, at symbol, at a domain, and that all the domains are going to be .com. So if we go up to the table, we can see how we can do wildcards. We see that it's a full stop, and then we have a plus quantifier matches the preceding token one or more times. And then we'll have to have the anchors on the start. So what we're going to do is we're going to jump into here. We're going to press up, and we're going to get rid of everything after the caret but before the dollar, and we're going to say wildcard plus at symbol wildcard plus .com, and hopefully that will give us all the email addresses. Now we used a backspace there as well because it escapes the regex operator, so it can be matched. So as you can see, because we're using .com, we don't want the dot to be a wildcard, so we're breaking out of the regex to say .com. And the question asks us, what was it, how many email addresses there were? How many email fit the above syntax? We have 1, 2, 3, 4, 5. How many emails? Filtering emails, how many unique domains are there? So we've got Gmail, which is 1, AMG, which is 2, Yahoo, which is 3, Fredfield, which is 4, TryHackMe, which is 5, Canary, which is 6, Hotmail, which is 7, and Alpha, which is 8. Make sure I don't count twice, so 8. Filtering for emails, what is the domain of the email with the local -part Lewisham44? So we need to look at the front of the email. Lewisham44 is amg.com. Filtering for emails, what is the domain of the email with the local part of MaxiMax? So MaxiMax is there, and it's fedfull.com. Submit that. Filtering for emails, what is the local part of the email with the domain hotmail.com? So we're going to come down to here, and it's HusseinVolt _Hussein.Volt. And the next question asks, filtering for URLs, how many URLs fit the syntax provided? And you can see filtering for URLs starts with either HTTP or HTTPS. Some of the URLs have www, and a TRD should exist. Now I'm just going to shamelessly steal this one from the video in the tutorial, and I'm just going to egrep. I'll explain what it's doing now. So we have the anchor, and then we're saying HTTP or HTTPS with a question mark. Then we have a wildcard. Then we're specifying any 3 characters. So that's : // We could do that with a regular expression. So we'd have to do a backslash to escape, then a // then a backslash to escape, then a // Nope, we'd have to do a backslash : // I think. Then we have www, which is optional. Then we have a wildcard. And then it asks how many URLs there are, and 13, 14, 15, 16. And then the final question asks how many of the URLs start with HTTPS. 2, 3, 4, 5, 6, 7. Lucky number 7. But yeah, that's the room. That's all the questions answered. Go read through it properly instead of listening to me. There's much more detail to be gotten from this room than what I've explained. And watch the video, because they do a better job of explaining regex than I do. Anyway, that's all I've got for you today. I hope you enjoyed it. Kind regards.